Dear students, we will start with the very first bit of modern surveying 5.1, that is GIS. This is the lecture 1 of the GIS. Basically, GIS is very well known, the tool which is being used everywhere and day to day life in our life. So GIS stands for the geographic. So let us start with the questions which would be asked in future. We will start with the very first question. So what are the most corona affected areas in your city, and what was the highest rates of the corona spreading in the city? So we all of knowing how with the rate the corona is spreading in the entire world. So day to day, what are the different death that is occurring in the world? So that would be in future to analyze why it has done so far, and in the statistical form, if you want to uh, come to some conclusion, so we need some database. So therefore some questions would be likely to ask in future, and the answer will be also need to be found out. Number one, what are the most corona affected areas? So how we can do this? The best tool is the GIS. So we will come to what is the components and subsets of the GIS. Second question, have you explored other types of information such as school locations, the parks, and demographics to try determine the best location to buy a new home? So if you want to buy a new home, what we will see, the best facilities nearby that the home we want to buy. So how we can do this? So either this uh, can be decided, the decision will be made based on what is the statistical data in tabular form, or it could be in the form of the map. So it is said that if a picture tells 1,000 words, a map tells 1,000 pictures. That is quite true. So if we inherently start turning that map into information by analyzing various layers to calculate either the affected area where the corona which is spread with being spread with the highest rate, or it could be the home which you want to buy, and where will be its most suitable location. So that suitability of a place for a particular activity, let us say buying of the home. So what we'll do first, either we see the statistical data or we will see the map. Mostly the maps where the pictures which say, or the pictures will give you the decision or conclusion in a short time. So therefore whenever we look at a map, it's what our eyes and minds do naturally start analyzing its content. So how we make the decision, we first analyze, but who is analyzing? Our eyes and our minds, in the form of finding the patterns. So if it first find what is the pattern in that locality, then what is the trend that we will assess, and after that we will make the decisions. So this is a process, and this process is called as a simply spatial analysis. So there is a word called as spatial. So spatial relates to the geographic data. Spatial means the entities or the objects related to the space. So therefore we call it as the spatial analysis. In one of the lecture we are also going in detail how the spatial analysis can be done. So here we'll just see, using spatial analysis we can combine information from many independent sources and derive new sets of information. So what we are using spatial analysis, this is one of the example we have just seen now, but there could be some complex problem which needs quick decision or sudden decision, and this can be done using collecting the different data. We see what is the difference between the data and information. So this information or data is combined together, and this data may be available at different resources. That could be in IT sector, corporate sector, or that could be a private sector, or that could be a government agencies. And after that, we will see find out the new sets of this the information, and that new sets of information will give the result uh, what we desire. Okay, paper map and GIS map. So far we have very much used the paper map, we have seen the paper map, but we are not aware of what is the GIS map. So basically we need to understand very first as the what is the paper map. The paper maps basically the which we have drawn different features on the map, which will be drawn with some scale, one suitable scale. So for example, the topographic map, so that map has some limitations. It cannot be produced for quicker and more effective storage of data. So if you start showing all different features on the on that map, it would be too much crowded, and some data which will be uh, cannot be effectively shown. And second thing, it cannot be shown relative to each other very precisely. Secondly, this paper map has communicative power, but which is also the limited one, because too many things cannot be depicted on the map. So it some uh, the entities may have missed out, so it cannot be possible to show here. Third one, it is only the static representation. What it means, if any change occurs, what will happen we cannot show on this paper. We have to redraw the paper with this what changes that have occurred in that particular area. And to prepare a small even map, a lot of efforts are to be taken. In what sense? We need to carry out the survey, and the collection of the data is not an easy task. Now what is the GIS map? Basically these maps, paper maps, what we have uh, get the information from that has to be transformed into digital form. There are different maps that we are also going to see, not only the maps, but it could be also some images taken from the aerial as aerial photographs, scanned photographs, or it could be a satellite images. So all this has to be converted into or transformed into the digital format. So this is nothing but your GIS map, and this GIS map enables the complex analysis and modeling. Until it is converted or transformed into the digital, we cannot use the softwares. So if you want to do the complex analysis, it uh, to get the results for any complex uh, can say the data, it has to be analyzed, and it requires the softwares. And after doing the software, we go for the modeling. Modeling is not the physical modeling. Modeling is a mathematical modeling. Mathematical modeling establishes the relationship between or amongst the different spatial features, that is the geographical features, and this modeling of the data which was not possible with the paper maps. Then unlike the the paper maps which are the static one, the GIS are the dynamic. Here in what sense, you can pan the map. That means we are very much concerned with the soft tools of this. It can be zoomed, and then it can edit it by turning the layers on or off. Then you can change the scale. Also, this is also possible in case of the digital format, and their perspective 1,000 times without any efforts at all. So simply you can exaggerate this without any changing any or doing any kind of the changes to the your digital format. As data is dynamic, as it constantly changes what has occurred. There are several incidents which take place in a particular area. Let us say uh, over some period of the time, volcano eruption or earthquake or flooding, whatever the natural event that occur constantly changes, is not possible to again and again repeatedly do show the changes on the paper map. But here you can show the changes, new data is being formed, and it is possible to uh, show this in the form of the digital format using enormous power of the modern computers. This is only possible. Some of the computers which require very large speed, which will analyze, and some of the data which doesn't require at all very powerful computers. Even our smartphones, they will also do the analysis, or even our laptop or PC, that will also do the analysis for this. So with these modern computers, the complex problem can be solved. It is possible to prepare thousands of maps representing the data from millions of records at a minimum time. So a very short duration, it is also such as a very supercomputer, it does all the changes or shows the output for this. So the basic question, what are the objectives of GIS? So if you see, very first thing is that there is huge enormous data, complex data, which need to be uh, categorized and managed. So very first thing, how to manage this, it requires very powerful computers, and secondly it should be done in very short period. So it will be used for the objective of this, it reduce the time. In what sense? The expensive activities such as different natural activities or the activities made by the human, these activities will involve very large data. So the GIS will handle all this data. Secondly, it will record all the data. That means it will store the data. And again, if you want to go for searching this human data, just like we are surfing the internet, so how this data is being in very short time, even a click of the mouse, that will be appearing on your screen. So what is this is nothing but an application of your GIS. Then third one is generating and establishing its geographical position of the different objects, or we call it the land features. So the GIS help you to establish the relationship between all the different features that will appear on even satellite image also. The primary goal of the GIS is to take raw data very first thing, because whatever the, for example, if you take the photographs, so that photographs only show the different features. The photograph doesn't have the sense to identify different features, but we having the knowledge of this can convert. So what are the different features? These are nothing but the data, but we have the knowledge of this, we identify this feature, and we can collect this data and form into particular category, that becomes your the information. So that will take a raw data and transform it by overlapping each other. So what is the overlap, that we will see also later on. Second primary goal is the various analytical calculations it will do and form a new set of the information that will be also very much essential for making decisions. So there are such different, as I said you, different complex problems are there, which requires the modeling, and that modeling is nothing but your mathematical modeling. That mathematical modeling involves some analytical calculations, and it will give you the best solution for this, for making the sudden decision. The need of the GIS, we have seen geospatial data are better maintained in a standard format. So very first benefit of this, maintaining is apart from maintaining, it has to be uh, in very standard format. Then the data can be revised time to time. So, and the updation of this data, that means any change are made, we can update this. Then either data or information, it is easier to search, analyze, and to represent here. We're also going to see how it can be represented. Then time and money, this is also saved. And last most, the better decision can be made within a short period, which is the best benefit of this GIS system. So whatever the data we require, this data has to be very good data. A great map needs great data, and this great data should be good data, but it should not be a junk data. So what the GIS does is that it collects the data and unwanted data that can be rejected. So that is the best use of this GIS. There are three basic levels at which the GIS works. The basic level we call as the data management. So in this data management, the data is captured, we call it the input, and this data can be stored in a proper file. Data can be retrieved, and data has to be that can be displayed in the form of results. So we are going to see in a moment what is the meaning of retrieving data and what is the displaying of the data. Then it undergoes the analysis. We call it as spatial analysis. There is a separate lecture on this spatial analysis. And the third one is the prediction. This is the highest level, the prediction, where mostly the questions will be to predict something, what happens if such and such condition occurs. So we'll take some example. Let us say for the data management, let us say there is the road, and we want to know uh, what is the width of this road or any highway. So the highway will include the information in the form of what is the width of the highway, what are the number of the lanes, and how much is the traffic count on that highway. Then if when we say the analysis, in the analysis, determining the shortest route between any two locations, that we call it is the analysis. And the prediction third is that for example, uh, there is a prediction of the effect of traffic on a particular area at a particular time. So this is called as that comes under your prediction. Second example, we can say predicting the effect of the flooding, or it could be predicting a particular effect on in any area by the earthquake. Okay, now we'll go for the subset of the GIS. It is in the subsets of there are four subsets. Data input. In data input, the data which is available mostly in the maps. There are different types of the map: topographic map, cadastral map, engineering maps. There could be data in the form of the aerial photographs. The data could be in the form of a satellite imageries also, or from different sources such as the digitized maps, the scan maps, and so many things. Data storage and retrieval. The data storage and retrieval subsystem organize the data, spatial or non-spatial types of the data, in a form which permits it to be quickly retrieved by the user for the analysis, and it permits rapid and accurate updates to be made to the database. So what is meaning of the data storage and retrieval? Then the third comes data manipulation and analysis. Here the subsystem that allows user to define and execute the spatial or non-spatial type of the data or the procedures to generate derived information. So mostly these are the the manipulation and analysis heart of the GIS. The last one is the data output and display. So data output that allows the user to generate the data in the form of the graphic displays. Normally these are the maps or the tabular reports. Mostly these data output are in the three forms: hard copy, soft copy, and the electronic form of this. But this data reporting maps, reports and plans that will indicates the available in the form as a display form. What GIS can do? Basically GIS can store and easily update large amount of the data. It can sort and store the special features. Special is nothing what we are going to see, special and non-special forms of the data. So special features into thematic layers. What is the thematic layers? Thematic the word comes from the themes. So here there are different layers, and all the layers have different sets of the informations. For example, there is the road network. In second layer there is a water body. Third is the type of the vegetation. uh, Fourth one, number of the colonies. So likewise the different layers are assumed to be, and all the layers, they are analyzed differently. If you say that this is the real, all to combine together different layers, that will form a real world. So real world is uh, divided into number of the layers, and each layer is treated or analyzed differently or simultaneously, what we can say. Otherwise it would be too complex to combine all together. Then third one, a complex spatial data can be manipulated, analyzed efficiently by layer rather than trying to drill entire, what I was talking about is. Then GIS can zoom into sections of the displayed data to generate additional graphics. So you can zoom and concentrate to create a different set of the information using the ID. Then GIS can import stored data electronically from different agencies or different sources, as I told you earlier, and thus save the cost of the collecting data. Now you might ask that if you are uh, collecting the information from different sources, they are not free of cost, but what are the charges for that collecting the different data from the different sources? These charges together are very less as compared to the creating new data, cost of the new data. Then the GIS can use the stored data to prepare maps at different scales, which is not possible with the paper maps, and it will create new maps by modeling. So this modeling is done using some of the softwares, and this one of the software is the ArcGIS or QGIS.